In this lesson, we'll go over the normal distribution. Specifically, we'll identify the conditions for a normal distribution. We'll learn to apply the 68, 95, 99.7 rule, and then we'll learn how to calculate standard scores. So first, the normal distribution. The normal distribution is a symmetric bell-shaped curve with one peak, and that peak corresponds to the median, mean, and mode of the distribution. Now, normal distribution is not to be confused with paranormal distribution. Its variation is characterized by the standard deviation of the distribution, and that's mainly what we'll be working with. Okay. So what makes a distribution normal? First, the most data values are clustered near the mean, giving the distribution a well-defined peak. Okay. The data values are spread out evenly across the mean, which means that each side looks the same, so that's what makes it symmetric. Larger deviations from the mean are rare, producing tapering values at the end. So again, picture of the normal distribution here. These values are rare, which is what makes the tapering tails there. And then individual data results come from a combination of different factors. Okay. So the 68, 95, 99.7 rule for the normal distribution. You may also see this as the empirical rule. Okay, so in a normal distribution, the portion of data concentrated around the mean is determined by the standard deviation. So I have the bullet points written out here, but on the next slide, I'm going to show a visual of what this is talking about. So first, verbally or written, data within one standard deviation of the mean on either side of the mean, so +1 or in the other direction, represents 68% of all the data. The data within two standard deviations of the mean represents 95% of all the data, and the data within three standard deviations of the mean represents 99.7% of all the data. So what does that mean? Let's take a look at this picture. So we have the mean, and we have one standard deviation going to the right and one standard deviation going to the left. You see these sigmas here at the bottom. You may also hear this as the Six Sigma rule as well. So between one standard deviation of the mean, whether it's to the right of the mean or to the left, this portion represents 68% of all the data. If we're two standard deviations away from the mean, that represents 95% of all the data, and then three standard deviations from the mean represents 99.7% of the data. So if you're given the mean and the standard deviation, there's a lot you can find out. Let's take a look. Detecting counterfeits. So vending machines can be adjusted to reject coins above and below certain weights. The weights of legal U.S. quarters are normally distributed. When you see normally here, think bell-shaped curve, with a mean of 5.67 grams and a standard deviation of 0.0700 grams. If a vending machine is adjusted to reject quarters that weigh more than 5.81 grams and less than 5.53 grams, what percentage of legal quarters will be rejected by the machine? Okay, so there's a lot of information here, a lot that's going on. When we're talking about the normal distribution, two important factors here, or two important pieces of information we're given the mean and the standard deviation, which means that we can construct a picture similar like this using the mean and then finding out what values are within one standard deviation, two standard deviations, three, etc. So when I approach this problem, my first thought is to draw a picture to visualize what's happening, and then I'll deal with the 5.81 and 5.53 grams when I get there once I have my picture. So I'm going to draw my normal distribution. Use your imagination and pretend it's symmetric. Okay, I'm given the mean as 5.67. Okay, now within one standard deviation of the mean, I'm probably not drawing this right, you add 0.07 to get to the next value. Erase. That's what it means to be one standard deviation from the mean, is you add the standard deviation to the mean to get the next value. So this is 5.67 plus 0.07, which gives us, I don't want to mess this up, 5.74. Okay, and then going the other direction now to fill in these two that are within one standard deviation of the mean, this would be 5.67 minus 0.07, which would give us 5.6. Let me switch colors now. Let's go to blue to find out what marks are 2 standard deviations from the mean. Okay, we're going to take and add 0.07, which would give us 5.81. We're going to continue to subtract 0.07, which would give us 5.53. Okay, and then lastly, 3 standard deviations away from the mean. Same idea. We're going to add 0.07, which gives us, I don't think I went that far, 5.81, 5.88. And you may not need all this information. I'm just drawing my picture. Minus 0.07, 5.46. Okay, so now we have our curve. Going back to the empirical rule or the 6 sigma rule, 68% of, I guess, the weights of quarters are going to fall between 5.6 grams and 5.74 grams. That's how to read this. 95% of the weight of all quarters is going to fall between 5.3 and 5.81. And then 99.7% of the weight of all U.S. legal quarters is going to fall between 5.46 and 5.88. Now that we have our picture, let's go back to the question to figure out what we're answering. If a vending machine is adjusted to reject quarters that weigh more than 5.81 grams and less than 5.53 grams, what percentage of legal quarters will be rejected by the machine? So I'm going to use red. So the machine's going to reject anything over 5.81 and anything less than 5.53. So that red spot that I shaded represents the weights that the machine is going to reject. Now, what we know from our empirical rule is that weights of quarters between 5.53 and 5.81 represent 95%. Okay, so that means what's going to be rejected is the remaining 5%, or 100 minus 95, which would be 5%. So the answer to this question, what percentage of legal quarters will be rejected by the machine? The answer there is 5%. Another example of implying the empirical rule. The scores on a psychology exam were normally distributed. Remember, when you see normally in this section, think bell shape, or paranormal, and then go to normal. With a mean of 61 and a standard deviation of 11. About what percentage of scores were less than 50? So I'm going to draw my curve again. I have a mean of 61. Okay, and I'm going to continue to build out. So scores within 1 standard deviation of the mean, this is 72 and 50. Well, there's the number I'm looking for. So you could stop here and go from here, or you could continue to draw the whole thing out. So since I'm covering this, I'm going to continue to draw the whole thing out. And let's pick another color. Okay, so the problem is asking what percentage of scores were less than 50. So what we're looking for here is this percentage, and I'm going to shade it in red, less than 50. So there's a couple of different ways to think about this problem. You can use what you know about the, well, we will use what we know about the 68, 95, 99.7. But take a look. Remember that the mean splits the data or the curve in half and that they're symmetric. So that means on the right-hand side, this has to be 50% of the data. Okay, so 61 onwards, that's where 50% of the data occurs. So now all we need to determine is possibly what this section represents between 50 and 61, and then we can do some subtraction to figure out the red part. Okay, so notice that, or recall that 68% of the data lies within 1 standard deviation of the mean. So those two sections together make 68%. Since this is symmetric, we can divide by 2 to determine what each section represents. So divide by 2 and we get 34% and 34%. Okay, so now what we're looking at here is that we have 50% to the right-hand side. Okay, so 50% and another 34%. So 34 plus 50 is all of the scores that are 50 and higher, and we can subtract in order to find the red section. How many are less than 50? So what this looks like, I didn't leave myself a whole lot of room here. We would take 100 because the entire set of values represents 100%, minus 50%, the right half, minus 34% scores between 50 and 61, and this would give us 16%. So 16% of all of the scores are less than 50. There's a diagram I have here that kind of details this, that shows each section. So rather than saying within one standard deviation and treating the whole yellow, for instance, as a block, it shows what each section is worth. So it takes it one step further. So since we know that the two middle pieces add up to 60, divide by 2 to get 34 and 34. Okay, so a diagram like this could be helpful for the last problem we just did. Okay? In order to find the green sections, we have to use some creative thinking here. So we know that everything from here to here is 95%. 68% of that has already been accounted for. So if we take 95 minus 68 is 27. Okay, so that means that the two green pieces add up to 27. So in order to get what those green pieces are equal to, divide by 2. I should have done those in green, huh? That would be 13.5. Okay. Same thing again, moving out. So we have 99.7% of all the data. So we have the purple, the green, and the yellow on each side. For that, let me use the color that it corresponds to. We could take 99.7 minus 95 because the 95 has already been accounted for. We're just looking for those small pieces, which should give us 4.7. So the two purples together add up to 4.7. Divide by 2, and that's how you get the 2.35. Okay. And now recall that everything under the curve represents the entire data set here. You might even have read or see in some of the homework problems that the area under the curve is 1. And that's if you take these as decimals rather than percentages. Okay, so if 99.7% of the data has already been accounted for, in order to find these blue sections, you would take 100 minus 99.7. Divide by 2, and this would be 0.15. So that's how we get those small little tails to be 0.15. This may or may not be helpful to you. It could help depending on what sections you're working with the problems in your homework. Next, let's talk about standard scores. So the standard score gives us a data value exactly where it lies in relation to the mean. The standard score gives the specific distance that a value is from the mean. And so typically standard scores are used to determine the percentile. So using the z-score or standard score and the properties of the normal curve, you can find out the data values percentile. So what the percentile tells us is how many values or what percentage of values are less than that. So for instance, on the SAT, if you scored in the 90th percentile, that means that 90% of scores were lower than yours. Okay. So given example 3, the IQ test is scaled so that the scores are normally distributed with a mean of 100 and a standard deviation of 15. Find the standard scores for IQ scores of 85, 100, and 125. So in order to compute the standard score here, you take the data value minus the mean, and these values could be negative or positive. Okay, if you have a z-score that's negative, it means it's less than the mean. If you have a z-score that's positive, it means it's greater than the mean, or a z-score of 0 means it's at the mean. Okay, so for 85, you would take 85 minus 100 and divide by 15 to get negative 1. For 100, 100 divided by 100, which is 0. 0 over 15 is 0. And then the standard score for 125 is 125 minus 100 divided by 15, and you get 1.67. Thank you for watching. If you have any questions, please feel free to reach out to me.